Let us look at the next section, students. This section contains 8 questions. The answer to these questions are in the form of double-digit integers. So let's start with question number 25. So question number 25, it says, X joule of work is done during the expansion accompanying the complete combustion of 1 mole of glucose to carbon dioxide in water at 20 degrees C when the external pressure is 10 atmosphere. Calculate the value of X. So if we try and figure out the reaction of combustion of glucose, so we have C6H12O6. It is getting combusted in presence of O2 to form CO2 and H2. So if we try and balance this reaction, we can have 6CO2 and we can have 6H2O. So in order to balance the oxygen, we have to have a stoichiometric coefficient of 6 for O2 as well. So now if we talk about the states of these species, the glucose will be in the solid form, oxygen will be gaseous, CO2 will be gaseous, and students at 20 degrees C, the state of H2O will be liquid. So students, if we talk about the delta Ng in this reaction, so the delta Ng value comes out to be equal to 0. So students, there is no change in number of gaseous moles during this combustion process, and as such, the work done will come out to be equal to 0. So students, the value of X is equal to 0, and for this question, we have to mark the answer as 0, 0. Let us look at the next question. Question number 26. A solution is 0.08 molar with respect to CCl3COH and 0.2 molar with respect to CH3COH. If the total H plus ion concentration is 10 to the power minus 3 molar and at a certain temperature, Ka for the acetic acid is 10 to the power minus 6 and Ka for trichloroacetic acid is A into 10 to the power minus 6, then we have to comment on the value of A. So if we try and figure out the dissociation of both these acids, so we can have CH3COH dissociating into CH3CO minus and H plus. The Ka given to us is 10 to the power minus 6. So the concentration of CH3COH given to us as 0.2 molar, and since the Ka value is very small, we can approximate the dissociation to be negligible. So we can have the formation of A molar acetate ion and A molar H plus from here. And if we talk about the dissociation of CCl3COH, which is the trichloroacetic acid, dissociate into CCl3COO minus and H plus. So the Ka value given to us is A into 10 to the power minus 6. So we can have the dissociation of 0.08 molar. So it is dissociating to give us, let's say, B amount of the ions on the right hand side. Now students, both of them are allowed to come simultaneously to equilibrium. So the H plus ion concentrations have to be added in both these reactions. So we can now form the expressions. So we can have A into A plus B giving us 0.2 into 10 to the power minus 6. Whereas we can have B into A plus B giving us 0.08 into A into 10 to the power minus 6. So if we add both these expressions, we can have A plus B whole square equal to the sum of the C into K values. So 0.2 plus 0.08A into 10 to the power minus 6. Now students, A plus B here represents the H plus ion concentration, which is given to us as equal to 10 to the power minus 3. So if you put the value, you can clearly see that the value of 0.2 plus 0.08A shall be equal to 1, which gives us a value of A equal to 10. So students, we can clearly see that for this question, we have to report the correct answer as 10. Let us look at the next question now. Question number 27. The pressure of a gas inside a cylindrical container fitted with a piston is maintained at 2 atmosphere. If the average velocity of the gas molecules inside the container is doubled by increasing the temperature, keeping the pressure same, then the volume of the container become V times of its original volume. And the value of 2V is. So students, if we talk about the velocity is proportional to under root of T. Now, if the examiner has told us that the velocity has become double, it means that the temperature has become 4 times. So students, if the pressure is constant and the temperature is made 4 times, then the volume also has to be made 4 times. So students, we can clearly see that the value of V is equal to 4, and since we have to report the value of 2V, we have to mark the answer for this question as 08. Let us look at the next question. Question number 28. A molecule normally absorbs the green wavelength, which is approximately 500 nanometers. At some temperature, if 1 mole of photons are absorbed, and it is observed that for every 20 molecules in the excited state, there are 54 molecules in the ground state, assuming that the pre-exponential factor is equal to 1. So it is given to us that the approximate temperature is T Kelvin, then we have to report the value of T into 10 to the power minus 3. Students, this ratio follows the Arrhenius equation. We can have N by N equal to A into e to the power minus delta E upon RT. We can take natural log on both sides to have ln of small n by capital N. The value of A given to us is equal to 1. And this will be equal to minus of delta E upon RT. So students, the value of N by N is given to us. N by N is 20 upon 54. So this is ln of 20 by 54 and the ln values have been given to us. So this will come out to be equal to ln of 10 by 27 and this is equal to minus 1. Okay, so this was the left hand side. We can talk about the right hand side now. So we can find out the value of delta E. So delta E can be written as Hc upon lambda. So H is 6 into 10 to the power minus 34. C is 3 into 10 to the power 8. We have to multiply Avogadro number for 1 mole of photons. And we have to divide by the R value which is given to us as 8. And the temperature we have to find out. There will be a minus sign as well. So now if we talk about the RHS on solving comes out to be equal to minus of 27,000 by T. So this shall be equal to minus of 27,000 by T. And the temperature value comes out to be equal to 27,000 Kelvin. So we have to report the value of T into 10 to the power minus 3. So T into 10 to the power minus 3 will give us a value equal to 27. Students, for this question, we have to mark the correct answer as 27. Let us look at the next question now. Consider the following reaction. So we have been given a series of reactions and we have been given a number of statements with respect to these reactions. So if we try and figure out the reaction sequence first, the first step is the hydrolysis. So in the hydrolysis step, we can clearly see that there is an ester group present. So this ester group shall be converted into an acid. So the product P1 is going to have two acid groups. And it is going to have this structure. So this is the product P1 which was formed. We can now see that the product P1 is allowed to react with ethylene glycol in presence of PTSA, which is the para-toluene sulfonic acid. So this set of reagent will cause the protection of the carbonyl group. So the product P2 which is formed in the reaction. Now this P2 is allowed to react with CH3 MgBr in presence of dry ether. So the CH3 MgBr in presence of dry ether is going to extract these acidic hydrogens. And we are going to have the formation of the conjugate bases. So the product P3 which will be formed is going to have this structure. So this is the product P3. Now the product P3 is allowed to undergo hydrolysis. So hydrolysis converts it to the structure P4, which is represented by this structure. And now this product P4 is allowed to undergo the Wolff-Kishner reduction. So the Wolff-Kishner reduction will convert this aldehyde into an alkane. So it will be converted to CH3 and we're going to have the formation of this structure. So let us now look at the statements given with respect to the above reaction sequence. So the first statement, it says, if the number of acidic hydrogen having pKa lesser than NH3 in P1 is X. So if you talk about the acidic strength of the groups present in the compound P1, we can clearly see that there are 3 acidic groups which have a pKa less than ammonia. So the value of X is equal to 3. If you talk about the second statement now, the number of moles of CH3 reacted with P2 is Y. So if you talk about the moles of CH3 you can clearly see that 3 moles of CH3 were used to extract these acidic hydrogens. So the value of Y is also equal to 3. If we look at the third statement given to us now, number of H plus ion gained by P3 to form uncharged P4 is. So this was the P3 and this is the P4. We can clearly see that the number of hydrogens gained is only 3. So the value of Z is equal to 3. And if you look at the fourth statement, it says that the value of X plus Y plus Z plus 1 is equal to A. So we can clearly see that the value of A is equal to 10 up till now. Some further information is given to us. So the next statement, it says, if P5 gives coloration with neutral FeCl3, then report your answer as A plus 1. So students, there is a phenolic group present in the product P5 and we can clearly see that we have to mark the answer as A plus 1. So the value of A was equal to 10 and we have to mark the value of A plus 1 as the correct answer to this question. So we have to mark 11 as the correct answer. Let us now look at the next question. Question number 30. Electrolysis of an acetate solution produces ethane according to the Cole-based reaction. So if we talk about the reaction, we can have the anodic and the cathodic halves. So we can have 2CH3COO minus giving us CH3CH3 plus 2CO2 plus 2 electrons. So this is the oxidation half. We can also have the reduction half. We can have 2H plus gaining 2 electrons and giving us H2. So we can have the balanced reaction now. We have 2CH3COH on the left hand side giving us CH3CH3, 2CO2 and H2. So students, in this system we can clearly see that for every 2 moles of electrons gained and lost, there is an evolution of 4 mole of gaseous compounds. So the ethane is also a gas, CO2 is also a gas and hydrogen is also a gas. So 2 farads will lead to the evolution of 4 mole gases. So 1 farad will lead to evolution of 2 mole gases. So we can now have the charge. The Q is equal to I into T. So it is given to us that the current of 0.5 ampere is passed for a total duration of 70 hours. So the 70 hours has to be converted into seconds. So 70 into 60 into 60. So we can now have the value of farads or the Faradays. So it will be given by 0.5 into 70 into 60 into 60 divided by 96000. So if we try and solve the value of F, the value of F comes out to be equal to 21 upon 16. So we can have the number of moles of gases. So number of gaseous moles will be double of this value, which is equal to 21 upon 8. And we can now apply the ideal gas equation to find the value of V. So students, we can have PV equal to nRT. The value of P is 760 mm, which will be converted to 1 atmosphere. So V is equal to N. The value of N was 21 upon 8. The value of R given to us is 0.08. The value of temperature is 300 Kelvin. So when we solve this expression, we have the value of V as equal to 63 liters. So students, for this question, we have to mark the correct answer as 63. Let us look at the next question. Question number 31. If number of different type of organic products that would be obtained after reductive ozonolysis of orthoxylene is X, then the value of X is. So we can have the structure of orthoxylene. So there are 2 resonating structures possible and we have to talk about both of them. So we know that the ozonolysis is going to convert this into dicarbonyl compounds. The bonds will break in such a fashion. So if we try and draw the structures obtained after the ozonolysis in the left hand side, we can have the structure. We can have glyoxal. We can have the third structure also as a glyoxal. Okay. We can now talk about the structure on the right. The structure on the right, when allowed to undergo ozonolysis, is going to give us this structure. Another mole of the same structure will be also formed, and there will be a formation of glyoxal as well. So if we try and figure out the number of different products which are formed, we can clearly see that this is the first type of compound which is formed. This is the second type of compound which is formed. This is a repeat of what we've already counted. This is also a repeat of what we have already counted. So we need not count this. And both of these are same as well. So we can count any one of them. And we can clearly see that there are three different type of products which are obtained. So students, for this question, we have to mark the correct answer as 03. Let us look at the next question now. Question number 32. 1 mole of each monoatomic, diatomic and triatomic gases are mixed. Cp by Cv for the mixture is x, and the value of 10x is. So if we talk about the Cv value first, so we know that a Cv value is given by N1 Cv1 plus N2 Cv2 plus N3 Cv3 upon N1 plus N2 plus N3. So students, if we put the value of N1, N2 and N3, you can clearly see that all of them are equal to 1. So we have 1 by 3 and Cv1. So the first gas is a monatomic gas. The Cv value is given by Fr by 2, where F is the degree of freedom. So we can have 3R by 2. We can have 5R by 2 for the diatomic. And we can have 6R by 2 for the triatomic. So this on simplification will give us a value of 14R by 6. So which can be simplified to 7R by 3. Now students, if we talk about the Cp of the mixture, the Cp will be equal to Cv plus R, as the average number of moles of gas is 1. So this will be equal to 10R by 3. So now if we talk about the gamma for this mixture, so the gamma mixture will be given by Cp mixture by Cv mixture. So we can now have the value of the Cp by Cv of the mixture. So the Cp value is 10R by 3 and the Cv value is 7R by 3. So this is a value equal to 10 upon 7. So 10 by 7 is equal to x, and the value of 10x is equal to 100 upon 7, which is approximately equal to 14.3. So if we talk about the nearest integer, we can clearly see that we have to mark the correct answer for this question as 14.